All right, we're going to evaluate these expressions. These have inverse sine, inverse cosine, and inverse tangent. And we're going to express our answer in radians. Now, the way I'm going to write this is I'm going to say that sine inverse of 1/2 is equal to theta. And this means sine theta is equal to 1/2. But theta is bound between negative pi over 2 and pi over 2. Now, because we're finding sine inverse of a positive number, we'll just look in quadrant 1. So whether it's sine inverse, cosine inverse, tangent inverse, if we're looking at those inverse functions of a positive number, we're thinking quadrant 1. That it's a okay. So then what we can do is there's different ways we can do this, but you can say, well, hold on, sine theta is opposite over hypotenuse, and that makes 1/2, and we can make a triangle that we sort of try to memorize. Here's 1 and 2, and if this is a 30, 60, 90 triangle, and if the short side is 1, the long leg is 3, and the hypotenuse is 2, and so we see that the theta is equal to 30 degrees, but we want to write our answer in radians. Now let's check out this next problem here where we have, I'm going to write cosine inverse negative 1/2 is theta. This means cosine theta equals negative 1/2. All right, well, now if I could, I would look in quadrant 1, but cosine is not negative in quadrant 1. Cosine is positive in quadrant 1, which is true of all the trig functions. So I go to the quadrant next to quadrant 1 where cosine is negative, the one next to quadrant 1, which is where cosine is negative, and that's quadrant 2. So if I were to, you don't really have to do this, but if you wanted to draw a picture here, you have here's 0, and in quadrant 1, both x and y are positive, but quadrant 2, x is negative and y is positive. X is cosine x. Now, I'm looking for one answer, and my answer is going to be between 0 and pi. That's how cosine inverse works. If it's degrees, it's between 0 and 180 degrees. Now, I am going to find a reference angle. I'm going to say, well, okay, cosine theta reference is adjacent over hypotenuse, and that's 1/2. So I take away the negative when I'm doing a reference angle, and I draw a 30, 60, 90 triangle where this time adjacent to theta reference is 1, and the hypotenuse is 2. So then opposite is rad 3, and that corresponds to 60 degrees. So theta reference is 60 degrees, which is also pi over 3. Here's pi, and if I back up by 60 degrees or by pi over 3, I get my answer of 2/3 pi. So I have 2/3 pi. Only one answer, not 2 answers or 3 or anything like that. So the answer is 2/3 pi. For these are functions. If you are using a calculator and you want in radians, they might give you a decimal answer. We want the exact answer. So if you are going to check on a calculator, I would flip the calculator to degrees, and then I would give you, well, pi over 3 is 60 degrees, so 2 of that would make 120 degrees. So it would give you 120 degrees, and then you convert over to the radians. But I want you to show your work. All right, this next one, I have tan theta is equal to -1. For theta, for tangent, we look between negative pi over 2 and pi over 2. My idea, my method, is I think of tangent as being the slope of the line through the origin. And I just ask myself, I do it pretty quickly, when do I get slope -1? When slope -1? What angle, what's that going to be? So here I have negative pi over 2 and pi over 2 here. So I'm looking for an answer for theta between negative pi over 2 and pi over 2. Notice for cosine, I'm looking between 0 and pi. In fact, I should probably, Okay, first of all, I have a little more room than I thought. Let's see if I move this down. Okay, and maybe the other one will move down. Oh, dangerous. Okay, why did I want to move that down is because I want to draw a picture depicting, I want to draw the one for sine. Now sine, when I do sine, sine is also between negative pi over 2 and pi over 2, but it includes the endpoints. Okay, so tangent doesn't include those negative pi over 2 and pi over 2 because tangent's undefined there. All right, so sine and cosine, or sine and tangent go, sine has between negative pi over 2 and pi over 2. Tangent is between negative pi over 2 and pi over 2. I mean tangent inverse, but I don't include the endpoints. But cosine inverse gives a theta between 0 and pi. Now, if I'm back to this idea of saying this is slope, well, where is slope -1? And we can see it's equal to, that gives negative pi over 4, or 45 degrees as a reference angle. So that's the answer to this one. You could also, if you don't like that idea of slope very much, you can also go ahead and, using a reference angle, say tangent theta reference is equal to 1, and you can write that as 1 over 1. And then you can see then that that corresponds with a 45, 45, 90 triangle. So you have 1, 1, rad 2, and that's a pi over 4. That gives the reference angle, or 45 degrees. That gives the reference angle. But because the slope is negative, where we are, and tangent is negative in quadrant 4. Because of that, we get negative pi over 4. Okay, so let me zoom in. There's a lot of zooming in and out. I know it's a little bit hard to follow when I do that. Okay, so again, if you were to check these, I suggest you put the whole thing on degrees, get an answer in degree, and then you put it into radians, because here we're asking for radians.
I had a question.
Uh-huh.
Could that also be written as 7 pi over 4?
No, and you'll see that if you use a calculator. It's a function. There's only one answer, and the answer has to be between negative pi over 2 and pi over 2. So so you have to write it. The only answer is negative pi over 4 in different units is negative 45 degrees, but it's not 7/4 pi.
Okay.
Yeah.
Can you explain